All right, so we're back, and today we're going to be trying to summarize a pretty epic interview
Yeah.
with Brian Cox,
Oh, Brian Cox.
the physicist.
Yeah.
Um, it was
Rockstar physicist.
yeah, the rockstar physicist,
Yeah.
right? It was a Joe Rogan interview, so it was a couple hours
Yeah.
long.
Yeah.
So we're going to try to boil it down to its essence.
Okay.
Try to,
Oh, cool.
but it covers a lot of ground.
Oh, yeah, it does. Yeah.
Everything from black holes to the future of humanity.
Right.
So let's just jump right in.
Yeah, let's do it.
Let's start with black holes.
Okay.
I mean, everybody loves black holes, right?
Yeah.
And Cox was talking about these photographs of the black hole from a couple of years ago.
Yeah.
And just how amazing that was, you know?
Yeah. I mean, the fact that we can even see them is incredible. But, the images themselves are one thing.
Right.
But think about what they actually represent. I mean, it's like we're seeing Einstein's theories come to life right in front of our eyes.
Yeah.
You know, that gravity warping the fabric of space-time. It's not just some abstract idea anymore. It's right there in the picture.
Yeah.
It's pretty mind-blowing when you think about it.
Yeah, and the scale of these things, you know?
Oh, yeah.
Like he was describing this black hole at the center of our galaxy.
Right.
And it's 6 million times the mass of our sun.
And that's not even a big one compared to some of the supermassive black holes out there, like the one in the galaxy M87 that was in the news.
Oh, right.
Yeah.
Yeah.
That one's 6 billion times the mass of the sun.
Wow.
I mean, can you even imagine? It's bigger than our entire solar system.
That's just incomprehensible.
Yeah, it really is.
So what are we actually seeing when we look at these photos, though?
Well, it's not the black hole itself.
Right, because it's black.
Yeah, exactly.
So light can't escape.
Right.
So what are we looking at?
Well, we're seeing its shadow.
A shadow.
Yeah, the shadow cast by the accretion disk.
And remind me what the accretion disk is again?
It's this swirling disk of gas and dust that's being pulled into the black hole.
Okay.
It's superheated and glowing.
Right.
And the black hole's gravity is so strong that it bends the light from this disk around it.
Okay.
And that's what creates that ring-like shape we see in the images.
So we're seeing light bending around a cosmic abyss. That's wild.
It is pretty wild.
Yeah, and it's not just light, right?
No, it's not.
You're talking about gravitational waves, too.
Oh, yeah, gravitational waves. Those are amazing.
Yeah.
They're literally ripples in space-time.
Yeah.
Caused by these massive events like black holes colliding.
So these are
He described them as like
going through us.
Yeah, he said they were like storms in time passing through us right now.
Wow, that's a great great analogy.
It is a pretty great analogy.
So these ripples from events that happened millions of light years away are passing through us like right now.
Right now? Yeah.
As we speak.
Yeah.
That's crazy.
Pretty incredible, right?
So what happens if you actually fall into a black hole?
Oh, that's the big question, isn't it?
Yeah.
Well, Cox actually debunked the whole spaghettification thing.
Oh, really?
Yeah, he said that with a large black hole, you might not even realize you've crossed the event horizon.
The point of no return.
Exactly.
Oh, okay.
He said it's more of a gradual process.
Interesting.
But the weird part is what happens as you approach the singularity.
The singularity.
Yeah, that's like the heart of the black hole.
Okay.
Where all the matter is compressed into an infinitely small point.
Okay.
And according to Einstein's theories, time essentially stops at the singularity.
Time stops.
Yeah.
So like you just freeze.
It's more than that. It's like time, as we understand it, ceases to exist.
Wow.
And it's not just time. Space and time kind of flip over inside a black hole.
So it's like the end of reality as we know it?
You could say that, yeah.
Okay, so what happens to all the information that falls into a black hole? Is it just gone?
Well, that's been a big mystery in physics, known as the black hole information paradox.
Yeah.
For a long time, scientists thought information was destroyed when it entered a black hole.
Right.
But newer theories suggest that information actually does escape somehow.
It escapes. But how can anything escape a black hole?
Well, that's where things get really interesting, because it might involve wormholes.
Wormholes.
Yeah.
Like tunnels through space-time.
Yeah, exactly.
Okay, now we're talking. But before we get sucked into that rabbit hole, let's switch gears for a second.
Okay.
Let's talk about another big question. Are we alone in the universe?
The age-old question,
Yeah.
right? Well, Cox dives into the Fermi paradox.
Remind me what that is again.
It's basically this. If the universe is so vast and so old, and there are trillions of planets out there,
Yeah.
why haven't we found any evidence of other civilizations yet?
Right. Statistically speaking, it seems like we should have by now.
You'd think so, right?
Yeah.
But all we hear is silence.
Yeah. And how did Cox feel about that?
Well, he had mixed feelings.
Okay.
He said, on the one hand, he'd actually be relieved if aliens landed on Earth tomorrow.
Relieved? Why relieved?
Because it would answer the question definitively. We'd know we're not alone.
Right.
But on the other hand, he's also worried that maybe we are alone.
And what did he say about that?
He said, quote, "If we're alone, then Earth is the only island of meaning in a vast, indifferent universe."
Wow, that's pretty profound.
It is, isn't it?
It really makes you think about our place in the cosmos.
Yeah.
And our responsibility to this planet.
Absolutely.
If it's the only one that has life on it.
It's a pretty big responsibility.
Yeah.
And that leads us to the next big theme, Cox explores. The future of humanity.
Oh.
What's next for us? Can we become a multiplanetary species? Will AI surpass us?
Wow, these are big questions.
They are, but Cox doesn't shy away from them.
Oh.
He pointed to the incredible pace of technological advancement.
Right, like technology's changing so fast.
It is. He compared a 1906 airplane to modern spacecraft.
Yeah.
Just to illustrate how far we've come in just over a century.
That's true.
But then he also talked about the challenges we face.
Like what?
Political instability, climate change, resource depletion, all these things.
Yeah.
So the question becomes, can we handle all this power?
Right.
Can our wisdom keep up with our knowledge?
Right.
And he shared this anecdote about J. Robert Oppenheimer.
The father of the atomic bomb.
Exactly.
Yeah.
And Oppenheimer was deeply worried about the potential of our creations to destroy us.
Yeah, he famously quoted the Bhagavad Gita, right?
He did.
After seeing the first atomic bomb test, he said,
"Now I am become death.
Now I am become death, the destroyer of worlds."
The destroyer of worlds.
Yeah, so he was really wrestling with the implications of what he had created.
He was. He saw firsthand the destructive power of our knowledge. And he believed we needed to apply the lessons of complex systems thinking to society.
Okay, what is that word?
It means recognizing that the world is interconnected.
Right.
That we can't oversimplify things or reduce them to black and white explanations.
Okay.
Especially in an age of misinformation where things are so easily manipulated.
Right, like with social media and everything.
Exactly.
Yeah.
He even uses this term reliable information.
Reliable information.
Yeah, emphasizing the need to be discerning.
Okay.
And to acknowledge what we don't know.
I like that.
Yeah.
Reliable information.
I think good term.
Yeah, it's like we're drowning in information.
They are.
But how much of it is actually reliable?
Right.
It's a good question.
It's a question we need to be asking ourselves all the time.
Yeah, and it's something we're trying to do here.
Right, absolutely.
So we're trying to cut through the noise.
Yeah.
Get to the heart of the matter.
And present the information in a clear and understandable way.
Exactly.
So people can make their own informed decisions.
Right, so speaking of getting to the heart of the matter.
Yeah.
Remember that black hole information paradox we were talking about earlier?
Oh, yeah. The mystery of where the information goes when it falls into a black hole.
Right.
Well, Cox brings it back
Okay.
and suggests that the answer might lie in wormholes.
Wormholes. Those theoretical tunnels through space-time.
Exactly.
Okay, this is where it gets really interesting.
It does, and it leads to one of the most mind-blowing ideas in physics. The holographic principle.
The holographic principle.
Yeah, are you familiar with that?
I've heard of it, but I don't really understand it.
Well, it's the idea that our universe, with its 3 dimensions of space and 1 of time, might actually be a hologram.
A hologram. Like those 3D images on credit cards.
Kind of, but on a cosmic scale.
So you're saying our reality is just a projection?
That's what this theory suggests.
Wow, that's a lot to process.
It is, but there's growing evidence to support it. Yeah, Cox even mentioned an experiment where scientists simulated a holographic wormhole.
They simulated a wormhole?
Yeah, in a quantum computer.
A quantum computer, what is that?
It's a type of computer that uses the principles of quantum mechanics to perform calculations.
Okay.
And they were able to create a mathematical representation of a wormhole.
Inside the computer?
Yeah, within the computer's simulated space.
So they're like watching the universe being booted up inside a computer?
It's a simplification, but you get the idea.
Yeah.
This research is giving us clues about how space and time might emerge.
From something more fundamental.
Yeah, something like a quantum computer.
Wow, that's mind-blowing.
It is. It's like we're on the verge of understanding the very fabric of reality.
Yeah, it's incredible.
And it's all thanks to the convergence of these different fields.
Like what?
theoretical physics,
Yeah.
quantum computing,
Right.
and experimental ingenuity.
Yeah, it's amazing what we can do when we put our minds together.
It really is.
So, from black holes to the edge of reality itself, it sounds like this Brian Cox interview was a wild ride.
It was a real mind bender.
And you've done a great job of summarizing it for us.
Well, I tried my best.
Yeah, you really brought it to life.
Thanks.
And I think what's so inspiring about Cox is that he never loses that sense of wonder.
Oh, absolutely.
He's clearly passionate about science.
He is, yeah.
And he wants to share that passion with everyone.
Yeah, he wants everyone to understand how amazing the universe is.
Yeah, and how much we still don't know.
Right. There's always more to discover.
And that's what makes it so exciting.
Exactly.
So I'm really looking forward to diving into the rest of this interview with you.
Me too. There's still so much to talk about.
But we'll have to save that for next time.
Okay.
So stay tuned for part 2 of our Brian Cox Digest,
Yeah, we'll be back.
where we'll delve deeper into the implications of these mind-blowing concepts.
It's going to be good.
It's going to be epic.
Yeah, see you then. So last time we're talking about the holographic principle.
Yeah, the idea that our universe is like a hologram.
Right, a projection from some lower dimensional surface.
I'm still trying to wrap my head around that one.
I know, it's pretty mind-bending.
It really is. Like, if our universe is a hologram,
Yeah.
what does that even mean for us?
Well, that's a question physicists are still debating.
Okay.
But the holographic principle suggests that everything in the universe,
Yeah.
from black holes to galaxies to you and me,
Yeah.
is ultimately encoded on this lower dimensional surface.
So, like, we're characters in a giant cosmic movie.
In a way, yes.
Wow.
But it's not just a passive projection.
Right.
Remember quantum entanglement?
Oh, yeah, that spooky action at a distance.
Right, where two particles are linked,
Yeah.
even if they're light years apart.
That one always blows my mind.
It's one of the weirdest things in quantum mechanics.
It really is.
But there's growing evidence
Okay.
that entanglement might be the key to understanding how space and time emerge.
Wait, so entanglement is connected to the holographic principle and to the fabric of reality.
It seems that way.
This is getting deep.
It is. Some physicists believe that entanglement might be the glue that holds space-time together,
Okay.
like a network of interconnected threads,
Okay.
weaving the fabric of reality.
So we're all entangled holograms,
Maybe.
existing on some lower dimensional surface. I think I need to lie down.
It's a lot to take in.
It is. But you know what's really exciting?
What's that?
This connection between entanglement, space-time, and the holographic principle
Yeah.
is starting to be explored experimentally.
Oh, absolutely.
Remember that simulated wormhole Cox mentioned?
Oh, the one created in a quantum computer.
Yeah, that was wild.
That's a great example of how scientists are starting to test these ideas.
Okay.
You're using quantum computers,
Yeah.
which exploit the weirdness of quantum mechanics
Okay.
to simulate these exotic phenomena.
So they're creating mini universes inside computers.
Not quite universes,
Okay.
but simplified models that capture some of the essential features of spacetime and entanglement.
Okay.
And the results are giving us clues that space and time might actually emerge from the interactions of these entangled quantum bits.
Entangled quantum bit.
Yeah, or qubits.
Okay.
They're the basic unit of information in a quantum computer.
Okay, so it's like watching the universe being booted up inside these computers.
In a very abstract sense, yes.
Wow.
It's still early days, but the implications are huge.
Yeah, it sounds like it.
We're on the cusp of potentially cracking some of the deepest mysteries of reality.
It's amazing to think how far we've come.
It really is.
This conversation has taken us from black holes to the very essence of reality itself.
And we're not even done yet.
I know. It's a lot to process.
It is, but it's also incredibly exciting.
It is. And you know, one thing that really struck me about Cox
Yeah.
was his emphasis on embracing uncertainty
Oh.
and being comfortable with not having all the answers.
Absolutely. In a world that often demands certainty,
Yeah.
he reminds us that it's okay to sit with the mystery.
He even suggested that this scientific mindset,
Yeah.
this comfort with uncertainty and willingness to be wrong,
Right.
is something we could all benefit from applying to other areas of life.
Like what?
Well, he specifically mentioned politics,
Oh, interesting.
where people often dig in their heels
Yeah.
and refuse to even consider alternative viewpoints.
Right. It's all about being right
Yeah.
and winning the argument.
But Cox is saying that maybe that's not the best approach.
Maybe we should be more open to being wrong.
Yeah, and to learning from each other,
Exactly.
even when we disagree.
It's about having a dialogue,
Right.
not a shouting match.
And that ties back to his point about complex systems thinking.
Oh, yeah.
Remember, he said we need to approach society with a complex systems lens.
He did.
Well, Just like the universe, society is a complex system.
It is, with all these interconnected parts.
And we can't just focus on isolated issues
Right.
without considering the broader context.
We need to think about the ripple effects.
Yeah, the ripple effects of our actions and policies.
And that requires listening to different perspectives.
Even those we disagree with.
Exactly. It's about finding common ground,
Yeah.
working together to solve problems.
And that's where I think Cox's message of optimism really shines through.
Oh, absolutely.
Despite all the challenges we face.
Yeah.
He believes in our capacity for reason, for collaboration, for finding solutions.
It's a refreshing perspective.
It is, especially these days.
Yeah, when it feels like everything is so divided.
Exactly.
He reminds us that even in a vast and seemingly indifferent universe,
Yeah.
we have the power to create meaning.
To shape our destiny.
Yes, and make a difference.
That's a powerful message.
It is.
And it's one that leaves me feeling hopeful,
Me too.
even as we grapple with all these complex issues.
It's a reminder that we're not powerless.
Right. We have agency.
We can choose to be part of the solution.
So what's next? Where do we go from here?
Well, I think the first step is to keep learning,
Keep asking questions.
keep exploring.
And keep an open mind.
Exactly.
Because the universe is full of wonder.
It really is.
And there's always more to discover.
So, join us for part 3 of our Brian Cox Digest.
Where we'll continue to explore these mind-blowing ideas.
It's going to be epic. You know, through all these complex topics.
Yeah.
What I really appreciate about Brian Cox is
Yeah.
that sense of wonder that he has.
Oh, totally.
You know, he just,
It's like he never loses that.
he never loses it.
Yeah.
It's so refreshing.
Yeah, he embodies that childlike curiosity
Yes.
that makes science so exciting.
Exactly, and he makes you feel like you're right there with him on the journey of discovery.
Yeah, and one of the things that really struck me was his point about knowledge and wisdom.
Oh, yeah, what did he say about that?
He said, our knowledge has in many ways outpaced our wisdom.
That's a good point.
And I think he's right, you know. We've made all these incredible advances.
Yeah, in science and technology.
But are we using that knowledge wisely?
That's the big question, isn't it?
Yeah, are we considering the ethical implications of our discoveries?
He brought up Oppenheimer again.
Oh, right, the father of the atomic bomb.
Yeah, who was haunted by the destructive power he helped unleash.
Yeah, and later on, he advocated for international control of atomic energy.
Right, he was warning about the dangers of a nuclear arms race.
He understood that scientific progress without ethical considerations could be really dangerous,
Absolutely, and it makes you wonder if we're making the same mistakes today.
like with artificial intelligence.
Exactly, we're developing these incredibly powerful AI systems.
Are we thinking carefully enough about the risks?
It's hard to say.
It's like giving a toddler a chainsaw.
That's a good analogy.
We need to develop the wisdom and foresight to use these tools for good.
And that wisdom starts with understanding the complexities of the world.
Right, like Cox was saying, we need to embrace nuance
Yes.
and avoid simplistic explanations,
Especially in politics and social discourse.
where things are often presented as black and white.
Yeah, but the world is much more complicated than that.
Exactly, and reducing complex issues to binary choices just prevents us from finding real solutions.
He even suggested that the purpose of democracy isn't necessarily for one side to win.
Oh, interesting. What did he say?
He said it's about creating a system where power can transition peacefully
Okay.
and dialogue can continue even in the face of disagreement,
That's a really important point, especially in today's world.
where everything feels so polarized.
Right, it's all about us versus them.
But Cox is saying that maybe we need to move beyond that kind of thinking,
Yeah, to a more collaborative approach,
where we can acknowledge our differences.
but still work together towards common goals.
And that ties back to his point about complex systems thinking.
Oh, yeah, remember he said we need to approach society with a complex systems lens.
Exactly. Just like the universe, society is a complex system with interconnected parts.
We can't just focus on isolated issues without considering the bigger picture
We need to think about the ripple effects of our actions.
and how they impact others.
It's about recognizing our interconnectedness.
And that's where I think Cox's message of optimism is so powerful.
I agree, despite all the challenges we face.
He believes in our capacity for reason,
For collaboration.
for finding solutions.
And for creating a better future.
It's inspiring, isn't it?
It is. It's a reminder that we're not powerless.
We have the ability to shape our own destiny.
And to make a difference in the world.
So after this deep dive into Brian Cox's mind,
Yeah.
what are our final takeaways?
Well, I think it boils down to this. Embrace curiosity, question everything, and don't be afraid to be wrong.
And never lose sight of the wonder and beauty of the universe.
Beautifully said. And if you've enjoyed this journey with us,
Be sure to subscribe to the show for more fascinating conversations.
we'll keep exploring the big questions and bringing you the essence of the most thought-provoking ideas out there.
Thanks for listening.